Let's now do more exercises on the equals method. Let's consider a first class called person. And very similar to what we saw before. So let's say we got the following attributes. We got string first name, we got string attribute last name, and also we got the weights and also heights for the person. You can simply assume that maybe the weight is in kilograms and the height may be in meters. If you want to extend your person class for calculating BMI later, you can also do so, but it's not covered in this exercise over here. And this is the equals method that's inherited from the object class, but we decide to explicitly override it, right? So that later on when we compare two persons by using the equals method, it's guaranteed to actually call this overridden version. Okay, that's something we discussed earlier. Let's have the following informal definition, and then it will be up to you to really translate it into Java. So let's say persons are equal if their names and also measures are equal. So the names includes per first name and last name, and the measures include the weights and heights. So how can you compare these four attributes over here to define the equals method? Okay, so that'll be an exercise for you just to warm up. I would suggest you at least grab a piece of paper to actually sketch your solution to the equals method to see the various branch statement you have to make, and also the typecast and the final return statements. And if you like, it will be even better if you can simply just go create a new Java project and then try to program this equals method from scratch. That will be very beneficial for your later labs and also programming tests. Alright, assuming that you paused the video and did some little bit of work to do the exercise, let's see how the method should look like. It's incredibly straightforward. So let's just look at that and then do some further exercises as well. Okay, so the first line will be just the first two lines will be very similar as before. So we simply say if this is equal to obj, if they refer to the same objects, return true. If dynamically they have the same type, we're going to if dynamically they don't have the same type, that's why not equal to. So we actually say return false. And notice one thing that's new over here. Earlier, the earlier version of the equals method, let me show to you. Let me give you another little brain teaser actually for you to think about. If you look at the equals method that we looked at before, for example, for point v2. So this part you have already seen in the person's equals method. But these two parts over here, you can see both of them will actually return false, right? So I kind of combine them into a single if statements. So that's the thing you will like to actually think about whether they are equivalent or not. I claim that they are equivalent. So these two branching conditions over here, satisfying either will actually return false. So now, would that be equivalent to what I'm showing over here on the slides? Over here, only a single one. I'm using disjunction. All right, so that's something for you to convince yourself. If you got any trouble thinking about it, you can reach out to me. Okay, let's move on. And then we also got this cast over here, because reaching this line, we know that the dynamic type for context objects and also obj, the arguments are the same, so that we can cast into person over here, right? Because the type for the context object must be the current class, which is person. Okay, and then we're going to return. So this is according to the definition over here, names and also measures. So we're comparing the first name, last name, weights, and heights. Okay, something like that. Okay, if you like, you can also try to embed maybe some tolerances. You can say it would be that the this dot weights, maybe the absolute value between this dot weight and other dot weights is within certain tolerance. But for simplicity, I will simply just use the equal. It's not the best solution, but you see the idea. Okay. All right, so that's about the equals method. Now I have several exercises for you to think about. Let me present them all to you, and then you pause the video and try to sketch your answer. They are not really like a programming exercises, but just to check out, verify your concept, your understanding. Okay, so this is our equals method over here. Again, let me just point out again. This part over here, and what you need to convince yourself is some extra exercise. Okay, so the exercise will be, why is this equivalent to the earlier version with 2 if statements. Okay, again, the earlier version looks like this. Over here, you can see we got 2 if branches over here, this and also this, and satisfying either is going to return false. And I'm now collapsing them into one single if statements over here, which are highlighting in orange over here. All right, think about it. Okay, so now the actual question I would like you to pause the video and think about. Let's go over one by one, and then I'll let you do the sketch of your answer. At line number 6, that's the first question. Okay, line number 6 over here. Okay, you can see, will there be a null pointer exception at the runtime if obj happens to be null? So for example, if I try to do something like, if I try to do p1 dot equals, let's say null. So here I'm assuming that the context object p1 is actually of type person, and it is not null. That's the assumption. But what if the obj over here is actually null? Right? You can see obj is the arguments over here. What if it is null? Are we going to get a null pointer exception? That's question 1. Okay, according to the code that we are given. And question number 2. At line number 6, what if we change it to, you can see this is what we have right now. What if we change it to the following expression? Okay, let me highlight it. And I hope you can see that the only difference is we try to do this one first, and then followed by disjunction, followed by obj equals null. You can see here, this obj equals null appear as a right operand as opposed to left. And also this part here appear as its first operand as opposed to the second. And what if we change it to this particular definition? Okay, that's the question for you. Okay, would it work or would it not work? If you believe that it wouldn't work, give me the problematic scenario where it wouldn't work. Final question. At line number 11 and 12, which version of the equals method is actually called? Okay, let me just highlight it. So let's say we go to, let me use green. So line number 11 and 12. 11 and 12, these 2 lines, you can see we are making calls to equals method here, right? So which version of the equals method are we calling? Are we calling the current version of the equals method here? Or are we calling the default version of the equals method from the object class or something else? Okay, so these are the 3 questions that are very important to verify your understanding. So pause the video and think about it, and then I'll go over the answer with you. Okay, assuming that you thought about the questions over here, maybe struggle a little bit, let's now go over the answer. And for the first 2, it's so important for you to make sure you understand the review on the short circuit effects for the logical operators. So let me just now put it here. So for Q1 and Q2, so make sure you understand about the short circuit effects of logical operator. But in this case, we're using the disjunction. Short circuit evaluation or short circuit effects. Right? That's something we just reviewed in the earlier part of the module. Okay? Short circuit effects. Let's talk about the first one. The first one here, what if object is actually happen to be null? So that means when we are evaluating this expression over here, if object happens to be null over here, let me write a little bit better. If that happens to be null, what's going to happen? So you basically got null equals null. Is that true or false? That one should be true, right? So that means this part over here, null equals null, is going to be true. And remember the short circuit effects. We say that for disjunction, as long as the first operand over here is already true, it does not really matter what the second operand is, meaning that its evaluation will be bypassed because the overall result will just be true. All right, it's really important. So this one here, you can think about this evaluation over here is evaluation bypassed. And what's more to that, the overall result for the logical disjunction is true. Okay, so this is important notes. Okay, so the evaluation will be bypassed, and also overall result will be true. All right, that's the question number 1. So that means we will not run into null pointer exception. So again, you can think about this constraint over here is a guarding constraint. Okay, so you can think about this is the guarding constraint. Guarding constraint for what? Guarding constraint for this particular method call, right? You can see when we try to call this particular method, we may run into null pointer exception if obj, the context object, is null. However, right now for the guarding constraint over here, if obj happens to be null, it's going to cause this evaluation for the first operand to be true, meaning that the short circuit effects for the disjunction is going to prevent the evaluation of this part over here from being evaluated. So that means we can bypass that potential null pointer exception, right? So that's really good, okay? So question number 2, kind of like a follow-up. So we know that this is a good guarding constraint. What if we swap its order? We put the guarding constraint over here, and then we put whatever expression that needs to be guarded as a first. The way I phrased the question here actually told you about the answer already, right? Let me just tell you what we saw earlier, right? Remember this example here? For both conjunction and disjunction, we know that having this or this is supposed to guard the division by 0 error at the runtime. But if you put it after the expression itself, it's not gonna be very useful at all, because the evaluation at the runtime is going to be from left to right. Okay, similar arguments over here. So the thing I really want to emphasize over here is the evaluation at runtime. Evaluation at runtime is from left to right. So this is going to be evaluated first, right? This is the leftmost, the left operand. Evaluating this first. Evaluating this first. In case obj is null, right? This is a context object. That's exactly the condition I set for question number 1, somehow to give you a hint. Evaluate this first, this method call first, if obj is null, will result in null pointer exception. All right, so this is like a counter example, like the scenario where this new version of the logical disjunction wouldn't work. Okay, null pointer exception in case object is null. Okay, and one more point over here. So that means this particular guarding constraint is not useful at all. So this guarding constraint not useful because it's not really put to be evaluated first. All right, so that's for question number 2. What about question number 3? At line number 11 and 12, which version of the equals method will be evaluated? And to really decide this, we need to look at the dynamic type for the context object for the method call for the equals method. Let's take a look. So let's say here, if you look at the context object, this the first name and this the last name. So these are, oh, let me just draw a little bit better. Let me just, okay. So these are the 2 context objects over here. So these are the 2 context objects. What's their type? This the first name and also this the last name. They were declared exactly over here. You can see first name is a string type, and also last name is also of string type. So that means their dynamic type are actually string. Well, you can assume that somehow it will be pointing to some string objects. Dynamic type for both is string, meaning that both of them will actually store the references to some string objects, one for first name, the other one for last name. So that's why when you want to invoke the equals method, it is actually going to invoke the equals method in the string class. Okay, so what I mentioned before about the default version of the equals method, well, maybe the overridden version of the equals method we're talking about right now, neither of them, neither. So it should be equals in the string class will be invoked. All right, so that's about the answers, like a quick, well, not really quick, and a very thorough walkthrough about the answers to these 3 questions. I want to show you one more thing, okay, just for completeness. Let's now switch to Eclipse. And if you go under the persons package and click on this JUnit test class, test person and collector, we're going to walk through this JUnit test class in much greater detail in the later part of the module. But what I want to show you to now, if you can look at the first test over here, and then go to line number 24, and then put a breakpoint over there. You can see we're calling p1.equals p2, whereas where p1 is actually the of dynamic type person over here. So we want to step into the execution of the equals method and to see which version it is going to call, right? We already know the answer from the earlier exercise, but let's double check. Okay, so let me launch the debugger over here and then switch to debug perspective. So now we're here. And as soon as if you move your cursor over P1, dynamically it's person class, right? You can see the address shows to you that it's a person object dynamically. Okay, and then if I say step into, I'm now in the equals method under person class, which is good. It's not the default version of the equals method in the object class. And let's now go on a little bit more, because remember the earlier exercise about question number 3. So what would be the version of the equals method that's being invoked over here? We know that should be a string, but let's double check. Okay, let's now just go back over here. If I say step over, and step over, okay. So what it is going to do is it is going to execute this equals over here, right? So what we want to do is we want to step into. Let's take a look. If I say step into, and also step into, right? So these are the first 2 lines over here has nothing for you, for you to step into. So that's why I just skip. Okay, let's say step into again. So hopefully this will step into the execution for this equals method. Let's take a look. If I say step into again, so now you can see we are now in the equals method under the string class, right? It really verifies our theory on the paper. Okay, that's basically what I wanted to show to you. All right, let's now stop, and then you can definitely go over if you wish, but that's kind of up to the Java string class implementation, which you don't need to know, right? But bottom line, you know that they're comparing the contents of the string objects. Okay, let me close them over here and go back to Java perspective. Okay, so that's about the equals method for the person class. I hope you're okay. And let's now go on to do another quick exercise as well. Okay, so the 3 questions I just walked you through, so they are all they are also documented in the slides. You can also go over them if you wish.